Let's have an introduction to sets. But before we proceed, let us unlock this word's difficulty. So first one, we have integers. So when we say integers, these are numbers that includes negative infinity, 0, and positive infinity. So that is negative 1, negative 2, negative 3, and so on from negative infinity, and 1, 2, 3, and so on in positive infinity. Next one, we have whole numbers. In our real number system, whole numbers includes 0 and positive infinity. So that is 0, 1, 2, 3 up to positive infinity. Next, we have counting numbers or natural numbers. So when we say counting numbers, it doesn't include 0, because when we count, we always start at 1. So that is 1, 2, 3, 4, and positive infinity. We also have even numbers and odd numbers. When we say even numbers, these numbers are divisible by 2. And when we say odd numbers, it's the opposite of even numbers, so it is not divisible by 2. We also have prime numbers. So when we say prime numbers, these are numbers that is only divisible by 1 in itself, just like 2, 3, 5, 7, 11, 13, and so on. Next one is composite numbers. When we say composite numbers, these are divisible by more than 3 numbers, or exactly 3, just like 4, that is divisible by 1, 2, and 4. And 6, that is divisible by 1, 2, 3, and 6. Next, we also have perfect squares. So we have 1, 4, 9, 16, 25, and so on. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and the like. And the multiples. So we are doing this by skip counting. It could be 5 by 5, by 2, by 3. So these are multiples. It's like when we skip counting by 2, so the elements in the set should be 2, 4, 6, 8, and so on. We also have factors. So these are the set of numbers which can be divided without remainder. So these are example of sets. So we have set A. We can see the pictures of shoes, hood, and a cap. Or it can be written also in words. And in set B, we have ball, doll, and a toy car. And in set C, we have orange, mango, and banana. Based on these examples, we can define set as a group or a collection of objects. So it is named using capital letter. Each object in a set is called a member or an element of a set. So every object that you can see, or every word that you can see, based from the previous example, is what we call an element. So let's take this example. Set A is the school days in a week. So what we should put in this set must be the school days in a week. So we have Monday, Tuesday, Wednesday, Thursday, and Friday. So these are called members or elements of a given set. So Monday is an element of set A. Thursday is also an element of set A, while Sunday is not an element of A because it is not included in school days in a week. Example number 2, we have set B is a set of counting numbers less than 5. So what are the numbers less than 5? So we have 1, 2, 3, and 4. If it is said counting numbers less than 5, based from the definition of counting numbers, it should always start with 1. So the least element in a set must be 1, and these numbers should be less than 5. So we only have 4 members or elements in a set. We have 1, 2, 3, and 4 to satisfy what is given in set B, counting numbers less than 5. Next one, set B is a set of primary colors. So what are the primary colors? So in set B, the elements that we have here are yellow, red, and blue, since these three colors are the primary colors. Now take a look at this. In set A, that is a set of even numbers, B is a set of odd numbers, and C is a set of counting numbers. So let's try to fill in the blank with the symbol for element or not an element. So let's try the first one. Is 2 an element of A, or is 2 an element of set A, wherein it is an even number? So it is an even number, and it is an element of set A. How about the next one? Is 7 an element of C? Is 7 a counting number? Yes. The third one, is negative 2 an element of C? So it is not a counting number. So it is not an element of C because it is not a counting number. Because counting number starts at 1 and should never be less than 1. How about 8? Is that an odd number? Obviously, it's not. Is 3 an element of set B? Of course it is. So it is an odd number. How about 5? Is that an even number? So no, that is not an element of set A. So now let's talk about well-defined sets. So let's take these examples. Set A is a set of primary colors. So it is a well-defined set since we can name primary colors. That is yellow, red, and blue. How about in set B? Set B is a set of beautiful girls in a school. So this is not a well-defined set since there is a word beautiful. And this is on how people perceive on girls in school. So this is not a well-defined set. So our example is of a well-defined set is set C. So that is set of months in a year. So we can name months in a year. That is why it is a well-defined set. And sets D and E are not a well-defined set since there's a word popular and excellent. Another one, we have an empty or null set. So when we say null set, so a set with no members or elements, so that is denoted by the symbol empty bracket for empty set, and this one for the null set. And set A is a set of triangles with 4 sides. So knowing that a triangle has only 3 sides, so we cannot name triangles with 4 sides. Set B is a set of months in a year start with letter B. So since we do not have month that starts with B, so again, that is a null set. Another one is a set of whole numbers less than 0. So since whole number starts with 0, negative numbers set are not an element of this set. So still, it is a null set. Next, we have the cardinality. So this refers to the number of elements in a given set, and it is denoted by the symbol n. So cardinality of a set A is written as n of A, or the cardinality of A. So we can simply determine the cardinality of set by counting the elements inside of it. Just like this one. Set A is a set of primary colors. So that is yellow, red, and blue. So we can say that the cardinality of set A is 3, since there are 3 elements in a set. Or set B is a set of school days in a week. So we have Monday, Tuesday, Wednesday, Thursday, and Friday. So the cardinality of set B is 5. So what if there is no elements in a given set? What will be its cardinality? For example, if set A is a set of days in a week start with A. So are we going to say that the cardinality of A is an empty set or a null set? So that is not a proper way, because we are talking about the number of elements. The cardinality of set A is equal to 0, since we are referring to the number of elements. So if it is an empty set, there is no element, so that is 0.